Module 1 Maths Error.
And my name is Dr. Norshuhada Rahman, and I'm covering for the topic of common math error. Nampak tu skrip dia pun menakutkan because math error ni sometimes it can happen secara tak langsung and it affects your result and as well as your grade. Ya, so dia one salah, silap-silap memang kematian lah resultnya pun. Okay. So there are a few types of error, including careless error. Obviously, name pun careless error is error yang kita tak sengaja lah kan. Yeah, so careless error, your minus, plus minus, tersilap, salin jawapan soalan salah, your factorization tersilap, all those things under careless error. Computational error, especially when it comes to calculator, computer programming, you masukkan silap, so your decimal places soalan soalan you masukkan decimal, you set your variables wrongly, so end up with the wrong results. Also position error involve that all those minus sign, decimal places, significant figures. Also bila you tersilap situ, you akan jadi precision juga kan, silap juga. Atau you kalau buatkan programming, you patutnya jadi real numbers, you make it a whole number misalnya, also it will falls under this precision error. Then you also there's one more under problem solving error. So for problem solving error, selalunya dalam kes you selesaikan masalah tak habis ataupun salah faham, so salah makna, you fahamkan masalah permasalahan dalam konteks yang silap, so you solve it wrongly because of your your mistakes in understanding the problems itself. Okay. Contoh-contoh yang daripada final examinations done by previous students. Let's say this one. Okay. Kesilapan careless mistakes yang sepatutnya macam atas dah elok-elok dan kesilapan berlaku di sini, silap masuk nilai, so total akan jadi silap. Sama juga dalam kes ni dah elok-elok, tiba this is supposed to be some real numbers over infinity, it should be 0, so jawapan sini dah salah, result akhir juga it's going to be salah. So sama juga dalam kes yang ni. Okay, dah elok-elok tiba-tiba ni Siti, AST, you ni nama kaedah tersilap, so overall akan ada penolakan markah juga di situ. All those is careless mistakes. Bukan tak tahu tapi careless mistakes. Also for this one, if you look at this one, this is also careless mistakes. Atas elok-elok tinggal ni your algebraic tersilap, basic algebraic tersilap, so also salah. Ni problem solving, halfway, atas elok tapi bawah tak selesai, so also under error juga, kesilapan yang keempat tu. Okay, sama juga saya tunjukkan lagi lah bagian ni. Ini melibatkan patutnya dah atas elok-elok tak tekan menggunakan you use degree instead of radian, so this is sign 2, so also it will affect your final answers. Okay, yang saya nak tegur dalam kes ni, kesilapan-kesilapan juga berlaku dalam konteks indeterminate form, IF. Ini juga dah pernah jumpa dalam diploma, dulu ya diploma level. Okay, and also the use of L'Hopital rule. Okay, so all this is indeterminate form, awak tak boleh selesaikan direct. So maksudnya bila awak jumpa bentuk-bentuk indeterminate form ni, kita kena olah. You need to change it into different form. Either you factorize, simplify dulu, ataupun you use L'Hopital rule or ada contoh kaedah-kaedah tertentu in order for you to solve it. You cannot just assume infinity ataupun ni potong, jadi satu salah. Ni also cannot direct potong jadi kosong atau jadi satu, wrong, salah konsep. Okay, for this one, misalnya 1 over infinity ni masuk direct ni ke x, so 1 over infinity is equal to 0, 1 over 0 from right hand side is positive infinity, 1 over 0 from the left hand side is negative infinity. All these things are the basic information and basic rules that you need to know in order for you to use in MAT 455. Okay, next ini. Okay, dia pun contoh-contoh lah, saya laju je lah. Contoh-contoh berlaku di student menyebabkan indeterminate form. So atas-atas dia elok, bawah semua salah. Division by 0. Okay. Apa-apa bernilai di atas real numbers over 0 is equivalent to infinity, atau dalam satu kes kita akan terus menggunakan as undefined. Ya. Kita boleh definekan value dia. So satu lagi kesalahan pelajar yang quite often berlaku in setiap semester, we'll see the same mistakes done by the students is in terms of bracket, the use of bracket or the minus sign atau square. Masalah square misalnya di sini square of minus 3. So penting kat mana bracket tu berada, sama ada di luar minus or di dalam minus tu. Ini satu, bentuk ini ke atau bentuk ni, because the result is different. Okay, sama juga with our olah factorization or expansion, bracket tu menentukan peranan kat mana, because this is not the same. So it will affect your final results. Okay, so sini sudah tentu jelas, saya tak bagi nanti tu akan lihat. Overall macam student actually they know how to do it, they remember the formula, but then they forgot about they mistakenly ni macam ni, eliminate. Mana boleh eliminate? You cannot eliminate k squared plus 5 dengan k squared yang tak boleh. So bawah ni confirm akan salah walaupun kat atas ni dah elok-elok. Okay, so pastikan tahulah konsep. Okay, ni just latihan sahaja kan. Okay, this is minus 9, di dalam kurungan, kuasa 2, so minus kali dengan minus, multiply with another minus is positive. Also this one, so second dalam, so you got minus 3 squared, you got positive 9. Okay, index pun banyak student melakukan kesilapan. So also, saya terus letakkan di sini, pastikan this is x squared, then you got a power of 3. Ini maksudnya didarabkan, didarabkan. So you got, it's not equivalent to x5 ditambah, actually you need to multiply x power 6 this. Okay, sama juga dalam ke bawah ni. Nampak pula yang ni. Okay, yang ni bila ada x kuasa 2 multiplied by x power 3, this one baru tambah. Kalau sini bahagi, ni darab tambah, kalau bahagi kita tolakkan kuasa dia. Okay, so that one's for x power 5 index. So ni just write orang lah, saya buka terus di sini. Okay, so ini tadi kita darabkan, sepatutnya jawapan jadi kuasa 9. Yang ni bawah ni salah apa? Sebab this is supposed to be kena darabkan lah ni, kuasa 7. Kuasa 7 salah, sepatutnya darab 12. Okay, then also involve with fraction. When you have with fraction, saya bukakan dulu yang ni. Okay, if you look at this one, okay, kat sini salah. Tak boleh kembangkan, ni kena expand this A, B plus C. Ni satu set ni, tak boleh kembang jadi macam ni. Unless macam ni, atas tu yang ada plus minus operational, divide by X, then X ni boleh bagi kepada CX and also 3 like this, boleh simplify. Okay, yang ni tu selalu berlaku, which I hope I'm not going to say it again for this semester student. Okay, you cannot cancel out this X. Okay, totally wrong. Okay, then fraction kan sama juga macam kes tadi lah, sebenarnya dah dalam bentuk darab, dan ini bahagilah 3 tingkat ni So yang ni terbalikkan, so this is A, B, C ni atas lah, terbalikkan, multiplied by C over B. So kita dapat yang ni, simplify, dan kita simplifykan dan dapat yang bawah ni A, C over B. Okay, okay, saya stop dulu di sini. Seterusnya nanti akan continue by Madam Siti Nurleena, our penyelaras for this particular code and native perfect. Thank you very much. We understand and get some benefits from this video. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Hi everyone, my name is Madam Siti Nurleena. I'm going to continue on topics of common maths errors previously presented by Dr. Nur Hanim. First, we're going to look at topic functions. What are the common errors that students do in topic functions? Okay, let's say we have two functions, fx and gx. So fx is equal to x squared plus 2x and gx is equal to x minus x squared. Let's say we have an operation of fx minus gx. So usually what student did was they just plug in all the value of fx and gx. Okay, like this example. We have x squared minus x squared plus 2x minus x. Okay, so we can see here that then we get the answer of x, which is wrong. So what are the correct solution? So students are advised to put bracket for each function. Let's say we have here the first bracket is fx, okay, and then minus the second bracket contain of gx. Then we can open the bracket, okay, and then solve for the negative sign, multiply with x, so we have negative x, negative multiply with negative x square, here we get positive x square. So we can see here that the solution is going to be 2x squared plus x. Okay, instead of the wrong answer which you get x. Okay, that's more on functions. Okay, let's say we have this question. Okay, fx is equal to fx squared minus x over 2. Find fx plus h. So we can see here that this function is for fx, but you have to find function for fx plus h. This means that you have to substitute all x with x plus h. Okay, so let's look at the solution. So here we can see that x squared has been substitute with x plus h bracket square, and then minus x plus h over 2. Okay, this is what usually student did. So you are advised to put bracket. Okay, you put bracket for function x plus h over 2. Okay, so that you can get when you expand the negative sign with the function inside of the bracket, so you get negative x over 2 minus h over 2. Okay, so you can solve this. Okay, in front here you can expand 4, okay, multiply 4 with all the function inside the bracket. Next, we're going to look at topic expansions. Okay, let's say we want to expand this equation. So we have x plus a, okay, outer bracket, square. So what usually students do that they just square the x and then plus square of a. Okay, so this is wrong. Okay, what you have to do, okay, the right way is, in order to expand x plus a squared is equal to first bracket of x plus a multiply with the second bracket of x plus a. Okay, this is the correct way. Okay, next you just multiply x with x and also x with a with x and plus a with a. So we get x squared plus ax plus a squared. So here we can see that we can add this one. So the final answer would be x squared plus 2ax plus a squared. Okay, not x squared plus a squared. Okay, another example of error in expansions. Okay, let's say this one. We have a constant in front of the bracket. Okay, so as usual, what student did wrong is that they multiply first the constant with the function inside the bracket. Okay, without expanding first. So this is wrong. Okay, so the right way is you have to expand first the bracket, the square bracket of x plus 1. Okay, so you will get 2 multiply with x squared plus 2x plus 1. Then you can multiply with the constant of 2. Okay, so these are the correct answer. These are examples from students' answer script. Okay, so we can see here that the student need to expand the question. Okay, so we can see here what are the student did wrong. Okay, this one is a careless mistake. Okay, we have 4xy, but when the student rewrite it, it became 4y. Okay, so this one is a careless mistake. And then this one, we need to expand this. So we have 2x squared multiply with x minus 2y. We can see that this student, okay, expand correctly for 2x squared multiply with x. Okay, supposed to be, okay, this one is an error also. Supposed to be 2x cubed plus, okay, this one should be 4x squared y. Okay, not 4xy squared. Alright, so this one again from a different student. Okay, when you expand x minus 6 square, you should put it as x minus 6 multiply with x minus 6. Okay, not x plus 6. Okay, another question. Here we have 10 plus 3 multiply with a function. Okay, an equation. So we can see here, this student just opened the bracket without multiplying it with 3. Okay, this equation should be multiplied with 3 before we add it with 10. Okay, and the second example, the student, okay, add the front of equation first, but this is wrong. You have multiply first with 3, then you have to add 10. Okay, so this student also get this answer wrong. Okay, let's move to factorization. Okay, how to factorize this equation? Okay, it seems easy, but when we have a multiple function, it became a bit complicated. Okay, let's compare first common function. So we can see here that we have x squared plus 5 power 3, and also the second part we have x squared plus 5 power 2. So basically we can factorize this. Okay, so we can factorize x squared plus 5 squared. Next, we look for another common. Here we have 3x squared, and on the second part we have 6x. So here we can see that we can factorize 3 and x. Okay, so the solution is, first we write the first factor that we can factorize, which is x squared plus 5 power 2. And the second one is 3x. Then we put the square bracket and write the remaining factors that are not being factorized. Okay, so simplify the one that's in the square bracket, and then the question is being solved. This some of the students' example on factorization that they got it wrong. So let's see this one. We can see here that this student has already factorized 6abc, but we can see here in the bracket there are still a's in all the 3 parts of equation, which means that this is a common factor that you can factorize. Okay, so this one, this student factorized a negative 2. Okay, whereas the question is only 2x squared minus 12x plus 18. Okay, there is no negative 2. If not, the student should put here negative x squared. Okay. Okay, surd. Surd is another name for square root. Okay, so usually we see this equation. Okay, surd of x plus a. What student usually did was they separate the equation. Okay, they put it as surd x plus surd a, which is wrong. Okay, you cannot do this. Okay, let's say we substitute x and a with a value. We're gonna see whether this method gonna give you the correct answer or not. Okay, let's say we separate set 9 plus set 16. Okay, so it's going to be 3 plus 4 and you end up giving an answer of 7. However, the right way is you have to plus 9 plus 16 first, and then you got set 25, and the correct answer would be 5. Okay, not 7. Alright. Here are the students' example. Here we can see the student going to solve set 2, 28 minus 3. Okay, what this student did was he minus 28 with 3 first. Then the student take the square root answer, okay, which is wrong. This student should square root 28 first, then minus the answer with 3. Okay. And this one also, okay, we have 10 set x minus 5. You cannot simply drag the set and then solve for 5 minus 5. Okay, this is wrong. You have to solve 10 multiplied with set 5 first, then minus 8 with 5, right? Okay, let's move to trigonometry. Okay, what is the answer for sin x over 2? Okay, not the answer. Okay, but what is the correct order in order to write sin x over 2? Is it sin x over 2 or 1 over 2 sin x? Okay, so we can see here that sin x and have an angle of x over 2. So this is different from this one. Okay, this triangle we have sin x. So the angle is only x, not x over 2. So the whole triangle of sin x is divided by 2, not the angle only. So for this one, we only have the angle that being divided by 2. So this one is the correct answer. Okay, so sin x over 2 is equivalent to 1 over 2 sin x. So how about cos x over 5x? So is it like this, cos over 5? Okay, some students, what they did wrong was they cancelled out this x. Okay, so leaving behind just cos over x. So we can see here that this cosine has lost its angle. So this is wrong. Okay. Next, we have cos x squared. So cos x squared is not equal to cos x bracket of square. Okay, we can see here that cos here have a angle that being squared. Okay, this one on the other hand was the whole cos x that being squared. Okay, so don't do this error when solving for trigonometry. So cos square x again is different to cos x squared. So you can see here that the square is not being at the angle but at the trigonometry. Okay, so this is equivalent to cos x bracket of square. Okay, so let's say we have 2 cos x plus cos 3x. Okay, so pay attention at the angle. So for the first equation, we have 2 cos x. So the angle only equal to x. But for the second part of the equation, the angle is 3x. So this one is not the same equation. So it is not equal to 2 cos x plus 3x, 3 cos x. Okay, we can see that in the second part, the 3 is being factorized from the trigonometry. So this is wrong. You cannot factorize any angle, okay, in order to solve trigonometry. Okay, so some students, when they factorize the 3 and then they add this equation. So 2 cos x plus 3 cos x is equal to 5 cos x. So this is wrong. Okay. So another example, we have cos 2x plus 5 cos 2x. So here we can see that this triangle have the same angle. Okay, we have cos 2x and then at the second part is also cos 2x. So here we can add the triangle. Okay, so we're gonna get the answer of 6 cos 2x. Okay, let's move to improper use of the formula. Okay, this one is improper use of the formula integration 1 over x dx equal to ln x plus c. So what are the common errors that student did? Okay, let's say we have this question. We have 1 over x squared plus 1. So we want to integrate 1 over x squared plus 1 dx. So what student did wrong was that they used this formula in order to solve this integration. So they're going to give an answer like this, ln x squared plus 1 plus c. So this one is an incorrect answer. And also like this equation, let's say we want to integrate 1 over x squared dx. So the student did wrong on giving answer ln x squared plus c. Okay, this one we have 1 over cos x. So student usually give answer like this, ln cos x plus c. So all these answers are incorrect answers. Okay, so what are the correct answers? So for integration of 1 over x squared plus 1, the answer should be tangent inverse x plus c. Okay, for integration of 1 over x squared dx, so the answer should be negative 1 over x plus c. And also the third one, for integration of 1 over cos x, the answer should be ln secant x plus tangent x plus c. Okay. Next, improper use of the formula in general. Okay, let's say here we have integration of set u du. So the answer would be 2 over 3 u power 3 over 2 plus c. Okay, why? Because we add the power of 1 over 2 and divide it with 3 over 2. Okay, so we will get 2 over 3 u 3 power 3 u power 3 over 2 plus c. And also this one, integration of u squared du. So the answer would be 1 over 3 u power 3 plus c. So what student assume from this formula that they can say that so integration of square root of anything should be 2 over 3 anything power 3 over 2. And also integration of anything square du should be 1 over 3 anything power 3 plus c. But this is not true. Okay. So this one is the example of the incorrect answer. Okay, so here we have square root of x squared plus 1. So from the formula previously, the student just put it as 2 over 3 in bracket x squared plus 1 power 3 over 2 plus c. So this one is an incorrect answer. And also here we have integration of cos square x dx. So the student directly, okay, using the misunderstood equation example just now. So they just put 1 over 3 cos cube x plus c. So these are all incorrect answers. So what are the correct answers? So here, for integration of square root x squared plus 1, the answer should be 1 over 2, okay, large bracket of x multiplied with square root x squared plus 1 plus ln x plus square root x squared plus 1 and plus c. So we can see that these are a huge difference of answer. Okay. For the second one, integration of cos square x, the answer should be x over 2 plus 1 over 2 sine 2x plus c. Okay. Dropping limit notation. Okay, this one is questions involving limit. Okay, this one is just a notation error. Okay, we can see here that what usually students did wrong in answering a limit question is, okay, they drop the limit notation, okay, during their operation of solving the limits. Okay, we can see here in our second part, there's no limit notation at this equation. And also at the third part here, there should be a limit notation here. Okay, why? Because this equation still have x. Okay, we do not yet solve the equation. So we should put limit x approaches 3 at each of these equation. Okay, so this is wrong. Okay, this is a notation error. Okay, so this one is the correct answer. Okay, as long as the equation still contain x, we do not yet substitute value of x. So you have to write limit x approaches 3. Okay, in front of the equation. Okay. Next, we have improper derivative notation. Okay, so this one is always what students did wrong. Okay, you can see here, fx is x multiplied with x cubed minus 2. Okay, then we expand it in order to differentiate. But the student directly differentiate within this function. So this is wrong. What you should do, after you expand, then you have to write the proper derivative notation, which is f prime x. Okay, you just cannot simply differentiate within the function of fx. Okay, so you should write the proper derivative notation of f prime x, which is equal to 4x cubed minus 2, right? Okay, laws of integration notation. Okay, so this one, we want to integrate x multiplied with 3x minus 2. Okay, so the student, usually they expand first and then integrate. But from here, we can see that there's a loss of integration notation in this second part. Because this equation is yet not been integrated. Okay, so the correct answer should be on the second part, you have to still write the integration notation because you still not integrate this function yet. Okay. This one is another one of loss of integration notation. Okay, here is proper integral. Okay, we have value, lower limit and upper limit. Okay, so usually the student expand correctly, yes. But let's see here, in the third part, this equation do not have the bounded value, okay, of the proper value, which is the lower bound and the upper bound. Okay, so the student should write it this way. Okay, we have to show that the value of the lower bound and the upper bound at the equation that we've already integrated. Okay, even though they have the same answers, but the notation, this one we call it as a notation error. So this can means loss of marks. Okay, that's all for these topics. Thank you and happy learning.